Okay, welcome to this AP check on electrochemistry and redox reactions. So electrochemistry is really the study of chemical reactions that cause electrons to move, and can we either utilize those reactions to produce an electric current, or do we have to use an electric current to drive that chemical reaction? So as we work through our electrochemistry, we're going to be studying both of those processes. And before we can even do that, we need to go back and brush up on redox reactions, and then we're going to kind of go that next extra step of looking at these reactions in either an acidic or a basic solution. And so that is where our focus is going to be with this check. And so I'm going to go ahead and start us off with the first one, which is to take a look at what happens in an acidic solution. Okay, so we're going to balance a reaction in an acidic solution. So a lot of this is very similar steps with using our half reaction method, but we're going to go ahead and then do those next tweaks to make sure that this is occurring in an acidic solution. Okay, so let's go ahead and take a look, and we're going to split each our two half reactions into separate reactions. So we're going to have our Br minus ion and our Br2. Okay, and then the next thing that I want to do is I want to go ahead and have my permanganate, so MnO4 minus, and our Mn2 plus. Actually, I usually put that over to the side, just a habit. You don't have to do that. Okay, so first thing we're going to do is balance all of our elements outside of hydrogen and oxygen first. And so the manganese is in the same amount on both sides, which is perfect. But I see that our bromine is not, and so we have Br2, so we have to put a 2 in front of the bromide ion in order to balance those. Okay, now we're good on those. Now, the next step, this is where it's going to be that acidic solution situation. We are going to go ahead, and so this is going to be taking care of that whole acidic solution. So this is the new part of this, okay? We're going to go ahead and balance our oxygens using H2O. So we're going to go plus H2O. And we have 4 O's over here, so that means we have to have 4 waters. So we have 4 O's, so we have to make sure we have 4 O's on the other side. And then once we do that, now we've added hydrogens to the right-hand side. So we have to go ahead and add our hydrogen ions. Okay, so that gives us 8 hydrogens on the right-hand side, so we're going to have 8 H plus ions to balance out the hydrogens on the left-hand side. Okay, so that part is done. Now, we want to go ahead and balance our charges using electrons. Okay, so here's our next step. Now, this gets a little bit trickier once we've added some of these together, so we'll go back and brush up on some of that. So on the top equation with our bromine, we see that we have 2 minus charges on the left-hand side because we have 2 of those bromine ions. So we're going to add 2 electrons to the right-hand side, and that balances those. And then on the bottom one, we have to consider that the 8H plus gives us 8 plus, and then we have 1 minus charge from the permanganate. And so that's going to give us a total of plus 7 on the left-hand side, and then we have a plus 2 on the right-hand side. So we're going to have to add, so plus 5 electrons, so that our charge on both sides is a net of plus 2. Okay, so net of plus 2 on both sides. Okay, now we have to go ahead and multiply our half reactions by a factor to get an equal number of electrons. So let's go ahead and do that. Okay, so here's our step 3. So we're going to multiply each one. So in the top one, we're going to multiply that one by 5, and the bottom one by 2, so we have the least common multiple of 10. So I'm going to multiply by 5 for the top one, and I'm going to multiply by 2 for the bottom one, and so that's going to give us 10, 5, and 10, and then we're going to have 10, 16, 2, 2, and 8. I'm running out of room down there. There we go. That's a pretty sloppy 8. 8. There we go. Okay. And once we've done that, then we can add all of them together. And so that's what we'll do for our final step here. We're going to add them together. So let's go ahead and do that. Okay, I'm going to add all of these together. Normally I wouldn't have to, but I'm going to start with my electrons and end with my electrons because we're going to end up canceling those electrons out. Of course, they're the same amount on both sides. So on the left-hand side, we're going to have 10 electrons plus 16 hydrogen ions plus 2 permanganates plus 10 bromide ions. And then on the right-hand side, we have 5 bromines plus 2 manganese Mn2 plus ions plus 8 H2O plus 10 electrons. Okay. Now that we've done that, we can go ahead and we can cancel out those electrons. They cancel out because we have the same amount on each side. Oops. And this is our net redox reaction balanced equation in an acidic solution. Now we're going to take a look at a redox reaction in a basic solution. And so this is actually very similar to the one in acidic solution, but we're going to add an extra step at the end to make it a basic solution. So basic solution here. So let's go ahead and start our process of writing each half reaction. So we have our S2 minus to just the solid sulfur in the first half reaction. Okay, let's go ahead and add in our electrons. So we're going to have plus 2 electrons to balance our charge. I'm just going to go ahead and do that first as I'm writing these. And then for our second equation, we're actually going to have to account for both the Mn and the S because it forms MnS. So we're going to have that S2 minus again plus MnO4, that permanganate. And that's going to give us our MnS. So it's kind of a little bit weird with that. That's why I like this one as an example problem. Okay, so we took care of both the elements and the charges, but now we need to go back and balance our oxygens and hydrogens. And so we see in this second one, we have 4 oxygens. So let's go ahead and add in our H2Os to the other side. So we're going to have 4 H2O. And then we're going to have to balance those H's, so we're going to have plus 8 H plus. Now remember, that makes that an acidic solution, so we're going to have to do some other stuff here to make sure that we don't have an acidic solution. So we balanced our charges using our electrons already. We did that for the first one. For the second one, let's go ahead and do that. So we have 2 minus plus another minus, so that's 3 minus and an 8 plus, so that's going to be 5 plus when I look at the net. Okay. And so we're going to have to add, there's no charges on the other side, so we're going to have to add that 5 electrons over here. Okay. Now we're going to multiply our half reactions to get a least common factor of 10. So let's go ahead and do that. So again, I am right here on step number 3. So we're going to multiply, the top one is going to be times 5, and the bottom one's going to be times 2. So that's going to give us 5, 5, and 10. And then down below we're going to have 10, 16, 2, 2, 2, and 8. All right, so that would be where we would stop and we would add everything up if we were just working with an acidic solution. But in a basic solution, we have to go through and do some extra stuff. So what I'm going to do is I'm going to add these up where they are right now. And so I'm going to go ahead and make this purple. I'm going to do step 4 here. I'm going to add my half reactions together and cancel out anything that I see on both sides. So we're going to see those electrons cancel. I'm just going to cancel them automatically. Okay. So I'm going to say these ones cancel out these ones here. And so we're going to have 16 hydrogens. Move this up a little bit. And we have 5 plus another 2 of the sulfur ions. And so that's going to give us a total of 7s2 minus. Okay. Plus our 2 permanganates, MnO4 minus. And then on the other side, we have 5 sulfurs. We have 2 MnS. And so we see that we have a total of 7 sulfurs on both sides. We want to double check that as we go through. And then 8 H2Os. Okay, so we are not done yet because we have to do that last step for number 5. So let's pull another color. We'll do orange for that one. Okay, so number 5, we're going to do orange. So it says add hydroxides to both sides of the equation to equal the number of H plus and combine to form H2O, okay, on the left side, and then on the right side, we're going to end up with some extra hydroxides because the H plus is on our left side. So we see that we have 16 total H pluses. So that means we're going to add 16 hydroxides. Okay. Now when I add these together, this is going to give us a total of 16 H2Os. Okay. And then I have to add that 16, running out of room here, OH minus to the other side. Now if you look at this, let's take a look at our H2Os for just a moment. Okay, I have 8 on this side and I have 16 on this side. So I'm going to cancel the 8 over here and reduce this to be only 8. So I'm going to cancel out those things that are on both sides so we can eliminate 8 of those. Okay. Now we're going to go ahead and write this total thing out for in our basic solution. So I'm just going to do a final total here. So we're going to have 8 H2O plus 7s2 minus 2 MnO4 minus 5s 2 big M little n s plus 16 OH minus. Okay, that is the balanced reaction in an acidic solution. Or excuse me, in a basic solution, not an acidic solution. Okay. So just one extra step. I find that most of the time we are actually looking at the acidic solution scenario, but it's possible to see both of them. And so this gives you an example of both.